if the physics are correct. My name is Kartik Raghavan, and today I'm covering why Clark Kent is a murderer. Let's look at the clip. Here we see Lois is hanging onto a helicopter for her life. Helicopter's falling, and she falls off the helicopter, surely to her death. But Superman comes in, catches her in about 15 seconds after her falling, and stops her in about a second and a half. You have Lois falling from near the top of the building, and Superman catching her some distance h. Let's look at our standard kinematic equation. That acceleration is the second time derivative of position. We can rewrite this as the integral with respect to time of the first time derivative. And this value here will give us the velocity. Solving this integral, based on the fact that our acceleration is negative g in the y-hat direction, we get negative gt plus our initial velocity, of course, all in the y direction. Considering the fact that Lois starts at no initial velocity, we can get rid of this term here. And we get negative gt for our final velocity. Plugging in our values, so our v final gives us negative g being 9.81 meters per second squared. And our time of 15 seconds for the fall gives us a velocity of negative 147.15 meters per second. 0.15 meters per second. Starting with this final velocity and using the impulse momentum theorem, the theorem that our impulse is equal to some change in momentum, which is also equal to the time derivative of the force acting on said object with respect to time. These are all vectors. Sweet. Starting with our change in momentum, our momentum final is equal to our velocity final times the mass of Lois, and our initial momentum is equal to the initial velocity of Lois times her mass. But we also know that initial velocity is 0, so this goes away. And this value here gives us delta p is equal to p final, which is equal to vf. For this integral here, let's assume that the force is constant over time, so that we can pull this force value right out of the integral and integrate a simple dt, which just gives us t. So this integral of f with respect to t is just going to be our force times the integral of dt into t, which of course just gives us t. Setting these two equal to each other gives us a final force expression. So force here is equal to, I think I missed a negative. This is going to be negative delta p. And yeah, so this is equal to negative vf times m over t. This time here is going to be the time that it takes Superman to catch Lois at 1.5 seconds. And assuming that Lois's mass is about 140 pounds, or I think around 63 kilograms, and plugging in, we get a final value of the force that Lois experiences for the 1.5 seconds of 6,272.72. This is 42.72 newtons of force. Let's put that number into perspective. So we have about 6,000 newtons of force. That is equivalent to a silverback gorilla falling straight on top of you, having fallen. A small car, or a baby grand piano, or even 4 full 55-gallon oil drums, all falling on you from a meter high. That's no small amount of force. In fact, the force to fracture someone's spine is only about 3,000 newtons. Meaning Lois here definitely sustained some injuries and is not looking at Superman and saying, "What's holding you up?" So, Superman is in fact a hospitalizer.